Hey, in this video, I wanted to go over some of the solutions to the random gas law problems. The key to these types of problems is reading the question and trying to figure out which one of the equations applies. All right, so one useful thing is just to go through and kind of label what the things information would be. All right, one of the first things to figure out is there something that's changing? All right, is there like words like going from and to, initial and final, all right? So in this one right here, you can see that there definitely is a change occurring, and we can label these things according to their properties, and we can use this and compare it to our equations and figure out that the appropriate equation would be the combined gas law, all right? And remember that the combined gas law is available in your reference guide. That would be right here. And so in applying this, the first thing that you need to know is what you don't, the variable that you don't know. So we don't know P2, so we need to get that all by itself. And anytime you have an equation that has a variable in the bottom, one thing that you can do to get rid of the variables in the bottom is to cross multiply. All right, that makes it a little bit easier to get this variable right here by itself. So we can solve for that. We get this expression right here. And then we go and we plug our values in. All right, I do want to point out that I changed this value to 5.0 liters. That gives us an extra significant figure and means that we're not going to have to round quite that much. All right, so after we solve for this, this is the number that pops out of our calculator. But then if you look at the numbers that go into the equation, you'll notice that it should be rounded to 2 sig figs. Notice that I also put a bar on top of that 0 right there, which means that this right here would have 2 significant figures. All right, so this would be rounded to 260 millimeters of mercury. All right, in number 2, all right, notice that in this case, again, we do have a change occurring. All right, we're releasing air from a balloon. All right, so labeling things, when you have moles, that is represented by N, all right? This is, these are your volumes, all right? So the appropriate equation would be this one right here. We're gonna cross multiply. That would originally give us this expression up on top, but we want to get N2 by itself, all right? And to do that, we're gonna divide both sides by V1. All right, that gives us this expression right here. And we're just going to go back and plug our values back into that expression, and we will get 0.72 moles. In number 3, the problem is a little bit different because there's no change that's occurring during this problem. We're just given a temperature, a pressure, an amount of the gas, and we're asked what the volume is. All right. Whenever you don't have any change, the equation is going to be the ideal gas law, which is PV equals nRT. All right. Notice that this also gives us a temperature in Celsius. And in order to use any of the gas laws, we have to have that in Kelvin. All right. So we need to convert that to Kelvin. We're going to solve for volume here, which gives us this equation right here. We're going to plug in our values, and this is what we would get as our volume. Right. In question number 4, there's definitely a change that is occurring, and we're talking about pressure and volume. All right, and the equation that you would be using if you're dealing with pressure and volume would be P1V1 equals P2V2. All right, the thing that we don't know, the last volume, we need to solve for. That would give us this equation right here. We then plug in for what we know, and we would get this number right here. All right, notice that I put these zeros after it because when you look at the number of sig figs in these, there should be 3 significant figures in the answer. And so you indicate that by putting these extra zeros right there. All right, and in question number 5, it asks us to figure out what an initial temperature is. So it tells us what the final temperature is. We need to figure out what the initial temperature is. All right. It gives us the original temperature the final temperature in Celsius. So again, even though it gives us a temperature in Celsius and asks us for a temperature in Celsius, we still need to put that into Kelvin when we're putting it into the equation. All right, so we're dealing with volume and temperature, so this would be the appropriate equation right here. We're going to cross multiply to get rid of the variables in the denominator. We are then going to divide by V2 so that we can get T1 all by itself. We're going to plug these into the equation. Notice also I changed the 7 liters to 7.0 liters to put an extra significant figure into that number. And when we calculate this, the answer that we'll get is 500 Kelvin. All right. So to indicate that this has 2 sig figs, we're going to want to put a bar over top of that second 0. All right. We then need to convert this Kelvin temperature to a Celsius temperature. And when you do that, notice that's an addition-subtraction procedure. All right. So if we subtract 273 from 500, where this is the furthest right significant digit, we would be required to round this at the same position. All right, so if we round 227 at the tens position, that would become 230 degrees Celsius.